And so in Algebra 1, we learned that a system of equations or inequalities is when you have more than one of them. And when you're solving these, you're trying to find the points of intersection, those xy points they have in common. For example, in this picture, this ellipse and parabola, well, they have 4 points in common. Okay? So if we were to solve them, we would be finding 4 xy points. This one over here, we have a hyperbola and a circle. This one happens to have 2 points of intersection. So when we solve this one, we would be finding 2 xy points in common. So earlier in the year, we talked about how we solve these systems of equations. How do we find those xy points in common? Well, the methods we discussed were substitution, where you would get y by itself or x by itself, and then substitute in, so you'll only have one variable. Elimination, where you're adding up the like terms and you're setting it up so you can eliminate one of the variables and therefore solve, for the other variable. Graphing calculator, points of intersection, we'll revisit that. And matrices, that we discussed earlier this year. Those can also be used to solve for the xy values. Okay, also recall, in this picture right here, it appears that we have 2 points of intersection. Okay, we saw this earlier, but you're not always going to have solutions. Not always will you have a point of intersection. I mean, just think simply, what if I had an ellipse? Oh, hold on one second. What if I had an ellipse like this and a parabola shooting off like this? Well, there's no point of intersection. Okay? Just something to keep in mind. Let's get into a problem. Let's solve this system of equations. Looks like we have 2 circles here. We have the sum of 2 squared terms, and their coefficients are all 1. So those are 2 circles. All right, well, let's first think about how we're going to do this. That's always a good idea. So elimination may not be our best bet, because if you think about that here, this is not the same thing. If I were to FOIL this out, we're going to have a lot more than an x squared. Same thing over here. So what about substitution? Well, if we got x or y by itself, that over here we'd have a plus or a minus square root. That plus or minus square root we would then plug in either here or here and then square it. That might not be our best bet either. That might make a mess. So what if we were to do this? This is always a option. What if we were to take this 20 and move it over, and take this 10 and move it over, and then that would be equal to 0. Excuse me, and that would be equal to 0. Then we can set them equal to each other. Let's do that. All right, so if we did that, hang on one second, let me move this over here. Okay. So that would give us an x squared, excuse me, y squared plus y squared minus 20 equals x minus 5 squared plus y minus 5 squared. And we move that 10 over, and we have a minus 10. Okay, let's FOIL that out and see what we get. Okay, this FOIL here gives us x squared minus 10x. That's an x. Plus 25. You're going to get the same thing on the y's. You'll get a y squared, a minus 10y, and a plus 25. And don't forget about your negative 10. Okay, let's combine our like terms. We have these over here, and that's a number. That's about it. But watch what happens when we do all these. Let's move over to the x squared and y squared. See what happens there. Aha, get rid of that one. And get rid of this one. All right, look at that. No more x squared or y squared. Cool. Let's see what we have left now. We have negative 20 on the left. That's going to give us a negative 10x, a negative 10y, and the numbers, we had 25, that's 50, 50 minus 10 is a plus 40. All right, we can get this into y equals mx plus b form. Why don't we do that? Let's see what happens. So I'm going to do minus 40 and minus 40, and I'm going to do a plus 10x. And a plus 10x. And that gives us a 10x. That is a minus 60. Equals that 0, negative 10y. And everything is divisible by Well, let's do negative 10 so we have y by itself. And that will give us a negative x plus 6, that's a 6, equals y, and that's a linear equation right there. Cool. All right, well, let's make this a little smaller. Let's look at the graph over here. What is that line we just found? Okay, well, let's change this to red. Well, let's graph this. The y-intercept and the slope is negative 1. So I have a y-intercept right there. Our slope is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, do-do-do-do-do-do. And that's the line that we just found. Oh, no kidding. What it is the line that cuts through both of these circles at the points of intersection. All right, so we kind of simplified it. So now what? Well, what if we now substitute in, because we now have an easier equation? There's a few different ways of doing it. Let's try this now. So in my first problem, we had x squared plus y squared equals 20. All right, well, now we know what y equals, so what if we were to do this? X squared plus y squared equals 20, but now we know y is negative x plus 6. Okay? All right, well, let's move that up here. What does that give us? That gives us x squared plus, that would be a negative x is a positive x squared. Negative 6, that would be negative 12x. And then a positive 36 equals 20. All right, so that's going to give us a 2x squared, a minus 12x, and I'm going to move that 20 over, so minus 20 gives us a plus 16 equals 0, minus 12x. Everything's divisible by 2, so what if we simplify our lives and make it x squared minus 6x plus 8, and over here 0 divided by 2 is still just 0. All right, well, that looks pretty factorable. That's going to give us what? That's x. Here, let's do this. All right, xx. So we need a negative 4 and a negative 2. Add them up. Not a negative 6. A negative 2. If you add them up, you get negative 6. And if you multiply them, you get a positive 8. Sweet. All right, so then let's make this smaller here. And, well, let's just get rid of that right now. That's okay, we can delete. All right, so now up here, let's just finish this off. Now, if we set them equal to 0, we're going to get x equals 4 and an x equals 2. All right, well, we want to find the points of intersection. The points would be the xy coordinate. So now, not that, just a parenthesis there. So we have a 4 and we have a 2. How do we find the y value? Plug them into any one of the originals. Well, you know what? Let's cheat. This is also going through those 2 points. Oh, that's not right there. So we could also use that one. That's going to share the same xy point. So what if that's the easiest one? So let's do that. So y equals negative x. When x is 4, that's a negative 4 plus 6. So that looks like the y value is a 2. And on the other one here, we have y equals negative x. Well, that would be a negative 2 plus a 6, which would equal a positive 4. And therefore, we have found our 2 points of intersection. All right, let's try this one out. All right, so again, what's our plan of attack? Think about how we're going to solve this one. All right, elimination is not going to be our best bet. We don't even have the same type of terms here. Substitution is definitely going to be the easiest. This one is very easily solved for x or y, doesn't matter, and then we can substitute in. I think, at least I'm going to try that one. So let's do that. If we simplify the top, it doesn't matter. Let's just solve for y. It doesn't matter which one you solve for. That's going to give us a negative 4x. All right, well, let's take that value and substitute it in for the y there. And that's going to give us x squared plus 9 times negative 4 over x squared equals 25. Don't forget your exponent rules. When you have a fraction, you square both of these, right? It's negative 4 times negative 4 and x times x, which would give us x squared plus 9 times 16 over x squared equals 25. All right, well, let's multiply that out. You're going to get, that's 144, 9 times 16 over x squared. Because remember, this is just 9 over 1, so you multiply the numerators and then the denominators. And that's going to give us 25. All right, what I like to do in this case, you've seen me do this before, is I like to look at my common denominator and multiply through by it. So the common denominator here is an x squared. So if we were to multiply both sides by x squared, let's see what happens. That would give us an x to the fourth. The x squareds here would cancel, and I'd have 144. And over here, we'd have 25x squared. I don't know if you've seen this one before, but check this out. I'm going to set it equal to 0 and put it in standard form. Okay, and now it's set equal to 0. Okay, notice this relationship. Instead of, well, here, let me get this. This right here is double that. All right, just like with the regular quadratic, you usually have an x squared there and an x to the first. Well, so long as that relationship holds, you can factor it the same way. So, what do I mean? Well, that would then look like this. We would have, I'm going to draw two parentheses, set it equal to 0. And what times itself gives us x to the fourth? X squared times x squared. Okay? And what two numbers multiply to give us this number, 144, and add up to give us this number, negative 25. Now, the first thing you think of with 144 is 12 and 12. Well, that's 24, not 25. But if you remember right back up here, we just multiplied a 9 and a 16 and got 144. So guess what? A negative 9 and a negative 16 would work just fine. And if you think about it, well, the x squared times x squared gives us x to the fourth. This x squared times this x squared gives us that x squared. And then negative 9, negative 16, there we go. Look at that. Beautiful. All right, and now all we have down here is a difference of two perfect squares. So if we solve them, what you're going to get, let's bring that right up here. Well, the left side, you should feel comfortable in saying that's going to equal x plus or minus 3. And the right one, the right factor, would be x equals plus or minus 4. Wow. That would be 4 points of intersection where they intersect at positive 3, negative 3, positive 4, and negative 4. Just to take a quick look at the graph over here. Well, that's not what I wanted. All right, well, graphically, this looks like this. Okay, what we do have here is a hyperbola and an ellipse. And you got to be very careful because if you look at this picture, quick glance, especially on that 83 or 84 where the pixels are horrendous, you're going to think that's two places. But if you zoom in here, well, forget even this picture. All right, let's zoom here. Let's do this. Hold on. Let's move this one to the front. If we zoom in on this one, okay, this is right in the middle there. Okay, it is very close, but you can see that there are, in fact, 4 intersection points. Okay, so you do have, you do have one here and here, they overlap, and the same thing over on this side. Okay, so just be aware of that. Okay, so let's get back to finishing this because we are finding the coordinates, and what we just found was the x values. Okay, so how do we figure out the y values? Well, you plug it into one of the originals, and I think it's safe to say that this one right here is the easiest one to plug in an x value to get a y value. So let's do that. We are going to have, hold on, let me change this to something green or red. We are going to have an x equals 3 and an x equals negative 3. And we're going to have an x equals 4 and an x equals negative 4. Let's find our y values. X is 3. When you plug in a 3 there, you get negative 4/3. And when you plug in a negative 3 there, you get a positive 4/3. Okay, over here, when you plug in a 4 right there, you get negative 1. And when you plug in a negative 4 right there, you get negative 4 over negative 4, which is positive 1. And there are your 4 points of intersection. Well, let's take a look at your outline now. Okay, so today we did day 9. And, alright, well, be ready to come into class. We're going to work on page 583. It doesn't specify algebraic solutions in the book, but we're going to work on them as well. Okay, see you then.